The question we are going to solve now belongs to test series 1. It is of control system subject. In specific, it belongs to Nyquist analysis of control systems. As per the question, the open loop transfer function of a unity negative feedback control system is given as g of s multiplied by h of s is equal to 100 multiplied by s minus 5 divided by s multiplied by s plus 10. We need to find the phase crossover frequency of the control system. From the given open loop transfer function, we can get g of j omega h of j omega as h of omega as shown. This is mainly obtained by substituting s is equal to j omega. So g of j omega multiplied by h of j omega is equal to 100 multiplied by j omega minus 5 divided by j omega multiplied by 10 plus j omega. We know that for at the phase crossover frequency of a control system, g of j omega p multiplied by h of j omega p will have the imaginary value as 0. That is, at phase crossover frequency of a control system, the imaginary part of g of j omega multiplied by h of j omega is 0. So, by rationalizing, we see that g of j omega multiplied by h of j omega is equal to minus j multiplied by 100 multiplied by j omega minus 5 divided by omega multiplied by 10 plus j omega. So here we rationalized only with j. So upon considering the next 10 plus j omega term for rationalizing, we see that g of j omega h of j omega is equal to minus j 100 multiplied by j omega minus 5 multiplied by 10 minus j omega and divided by omega multiplied by 100 plus omega square. Upon seeing the above term, we can say that the imaginary part of g of j omega h of j omega equal to 0 implies omega square minus 50 is equal to 0. That is, omega is p is equal to root 50 radians per second. From this we see that for the given g of s multiplied by h of s, the imaginary part of g of j omega multiplied by h of j omega is equal to 0 at omega p equal to root 50 radians per second. So from this we can say that the phase crossover frequency of the given control system is root 50 radians per second. Hence the correct option is